Welcome back to Summarize Science. Today, we're looking at a fascinating new paper about making robots much smarter. Ever wonder why robots, even advanced ones, can seem a bit clumsy or get stuck easily? A big reason is that they often act without truly understanding the consequences of their actions. They can follow a script, but they don't really see the future. Currently, researchers have two main types of models for this. First is a vision language action or VLA model, which you can see on the left. Think of this as the doer. It sees an image, reads a command, and then generates an action. But as the chart shows, it lacks imagination and an understanding of its own actions. The second type is a world model, shown in the middle, which is like a thinker. It can take an image and an action and predict what the world will look like afterward, essentially simulating physics. But it can't decide what action to take in the first place. This is where a new model called RheinVLA-002 comes in, from researchers at Damo Academy and Zhejiang University. It's a breakthrough because it combines both the doer and the thinker into a single, unified system. As you can see in this diagram, it's designed to both understand the world to generate actions and use those actions to imagine what happens next. Essentially, the two parts of the model teach each other. The action-generating part helps the robot understand what's in an image and what to do with it. At the same time, the world model part, by predicting the future, helps the robot understand the physics of its environment. This joint learning process makes the whole system much more powerful and robust. And the results are pretty stunning. The team tested RheinVLA-002 on a standard set of simulated robot tasks. As you can see in this table, it achieved an incredible 97.4% success rate with its continuous action model. This outperforms many other leading models, and it did this without any large-scale pre-training on other robot data. But what about the real world? They tested it on a real robotic arm with tasks like place the block in the circle. Again, RheinVLA-002 performed exceptionally well, especially in cluttered environments with distracting objects. It surpassed other powerful models by a significant margin, sometimes by as much as 30%. To prove how important this combination is, they ran tests with and without the world model component. This visualization shows it clearly. On the top, the robot without the world model fails to grasp the object. On the bottom, the full RheinVLA-002 model, which has learned to imagine, keeps retrying until it successfully grasps the cheese. This shows that the world model helps the robot focus and understand object interactions, not just follow a blind path. So, let's recap the key breakthroughs here. First, RheinVLA-002 unifies two different types of AI models, one for acting and one for predicting the future. Second, these two models learn together and enhance each other, creating a system that is greater than the sum of its parts. Finally, this allows robots to better understand physics and object interactions, leading to massive performance gains. What does this mean for the future? This approach could lead to robots that are far more capable and adaptable. Imagine warehouse robots that can handle novel items without dropping them, or household assistants that can clean up a messy room by predicting the most efficient way to do it. By giving robots a form of imagination, we're taking a huge step toward creating machines that can truly understand and interact with our complex world. That's all for today on Summarize Science. Thanks for watching.